So, throughout our summer semester, we've focused on the environment in various areas, whether it's understanding pollutants, the atmosphere, or acids and bases. Our focus has always been on how humans have changed this world. Now, these changes, however, not always been the best thing for the environment or the earth. Now, I'll be presenting on the topic of acid rain and how it impacts fish. So, acid rain has been a topic discussed for a good reason. Humans contribute to this problem on a daily basis with our pollution habits. There are various pollution habits, but a few common habits would be the excess use of cars on the roads in the United States, and also the use of coal in factories and energy plants. Acid precipitation is produced through the release of nitrogen dioxides and sulfur dioxides into the atmosphere. As you can see on slide 3, nitrogen and sulfur are both paired with two oxygens each. Now this next slide shows the end users of these toxic wastes. As I said earlier, car emissions and power plants are large contributors to acid rain, specifically with their release of nitrogen dioxide. However, when sulfur dioxides are released, it is usually through the process of burning coal and or smelting metals. Now, on their own, these two chemical gases are not acidic. However, when they combine with water, they can create an acidic solution. Uh, when added with water, these create the nitric acid and sulfurous acids that we have talked about and learned about throughout the semester. So now as we turn to slide 6, acid rain can be found and is associated with numerous forms of precipitation. As demonstrated below, it can be found in rain, fog, and snow, to name a few. Now on the next slide, the map portrays the sulfite ion wet disposition across the United States. As you can see, in 1990s, some areas of the East Coast and moving west a little bit were extremely dark red, meaning they were greater than 32 kilograms per hectare. Fortunately, from 2014-2016 range, the map is much better looking. These measurements have been cut in half and maybe sometimes a little bit more, with only minimal sulfate dispositions in the factory hub areas of the United States. For example, in the Midwest would be the Pittsburgh, Pennsylvania area and Ohio in that Midwest region. Also, east of Texas, including Louisiana and Alabama, that region are some factory hubs in which are still release a significant amount of sulfate ion. The reason for this cut across the country will be addressed on the next few slides. Now this slide depicts the average pH across the country. Again, the East Coast and part of the Midwest are impacted significantly by very low pH levels, while the West Coast and most of the Midwest experience healthy pH levels of around 5. Fortunately, most of the pH levels in the United States have returned to more normal figures as time has passed on due to the restriction placed by the government on corporations, factories, and automakers to decrease the amount of pollutants in the air. And those who don't know, slide 10 portrays the complete cycle of acid rain. Now, as I said, it starts with the emissions from factories or cars themselves. It then travels into the air, which is later absorbed by various precipitations that I mentioned earlier. And then eventually it gets dropped back down to the Earth's surface through rain, through snow, And this acid rain can be absorbed in a variety of ways once on the surface. This variety of absorptions will be demonstrated on the next slide. Now, acid rain impacts a variety of things on the Earth's surface and also below the Earth's surface. The 5 areas that are negatively impacted are metals, more specifically bridges. The rusting on bridges are a severe area of caution across the country. Human visibility, the decrease and the breakdown of limestone, forests and trees, and most importantly, lakes and streams. I will be focusing the rest of the presentation on acid rain penetrating both lakes and streams, which inevitably affects the wildlife in these fresh bodies of water. Acid rain reaches lakes and streams first, and obviously through rain itself. Rain can directly fall into these bodies of water and impact their pH levels. Another way that it reaches lakes and streams is through the runoff waters that eventually flow into lakes and streams along the way. Now, this runoff water often flows through soil and attracts and brings aluminum from the soil along the way to the waters. The more acidic the rain is, the more aluminum that is actually brought along the way through the soil and then into the waters themselves. A few species of fish that are commonly found in fresh bodies of water are trout, grayling, salmon, and pike. Now, these species can tolerate a variety of pH levels in the water. Unfortunately, that's a little bit troubling to manage the right pH level in these lakes because you can't really get it right for all species. Some get affected and some don't. In my experience, I know a lot of fishermen on the East Coast that are really disgruntled by the loss of fish population over the years in their favorite fishing holes or favorite spots. Now, on slide 14, it demonstrates the pH scale itself. I know we talked about this in some of your lectures and also in the readings as well, but I thought it would be important to highlight. Where acid rain starts is depicted on the scale, as well as where fish start to die off. Acid rain and acidic lakes are anything below a pH level of 5, really. As you can see, rainbow trout start to die at only a pH level of 6. Other varieties of fish struggle to survive when waters hit the 5 to 5.5 pH level mark. And essentially, all fish die when waters obtain a pH level of 4.2 or below. Acid rain harms fish due to the decrease of calcium in the water, which reduces the reproduction of fish, among many other things. This calcium loss can also damage fish eggs and often make them too weak to even hatch. These levels of calcium can also weaken the bones in adult fish. An important thing to note is the die-off of fish happens over time through the decrease of reproduction, the decrease of hatching eggs, and the die-off of adult fish earlier than they're supposed to be. So that basically occurs, and the extinction of fish slowly comes about. And at extreme low pH levels, acid actually begins to damage the fish's gills. Now, the acid molecules in water create mucus in the gills of the fish. When the mucus in the gills become too thick, the fish can actually suffocate in the waters that they've swum and lived in for their whole life. And this is due to the lack of oxygen that is being obtained through their intake through the gills of the water. And for those reasons, acid rain is a detriment to the fish population among freshwater fish all over the country. Now, lastly, I have a reference slide of all my sources. Thank you, and I hope you enjoyed my presentation.